Understanding the Basics of Logistic Regression Part 1. By the end of this topic, you will be able to describe the use case of logistic regression, explain why logistic regression is a classification algorithm, explain how logistic regression is different from linear regression. So far in this training, we have been working with the dataset of housing prices. In that dataset, our objective was to predict the sale price using the given information of the house. Now in this module, we will be looking at our first classification algorithm known as logistic regression. Now what is classification algorithm? Well, before we discuss the classification algorithm, let's do a quick recap of the previous problem. So far, we have been dealing with a problem where we had to predict a continuous target variable, that is, how much of something. For example, in linear regression, we were trying to predict how much a house would sell for, and the house price here is a continuous numerical variable. In classification problems, we will be dealing with a categorical target value. To refresh your memory, a categorical value is one which represents a characteristic which cannot be measured or counted. Now, I can already see your next question. If logistic regression is a classification algorithm, then why is there the term regression in its name? I will not answer this now, but I promise that I will answer this as we go along. To understand classification problem and categorical target variable, consider an example where some students are enrolled in an online machine learning training just like you are. Now after 20 days of the batch start date, the organizer of the training surveys the students about their purpose behind joining the training, as we also did for you at the start of this training. Let's say this plot shows the results. In this plot, we can clearly see that the students who are investing a great deal of time in the training are the ones who are actually seeking a new job or a job change. Now based on our existing knowledge, if we were to build a predictive model, linear regression would look something like this. Now, if we look closely, we can clearly see that the regression line is not generalizing the data very well. But if we project on the x and y axes as shown in the figure, we can clearly see that we can declare it as a threshold value. In this case, the threshold value on the y-axis is 0.3, which tells us that whenever the regression line generates a prediction over the value of 0.3, we can consider it as a job seeker, and whenever the prediction of the regression line is less than 0.3, we can consider it as not a job seeker. Makes sense, right? Now you might be wondering, why are we even discussing the logistic regression if linear regression can handle the classification problem? Using linear regression in this case actually poses two issues. Firstly, the linear regression line is very susceptible to the outliers. Consider that a student completes the 200 hours worth of training in 20 days. In this case, he will be an outlier who will appear on the far right hand side of our plot, as shown in blue. So how do you think this new point is going to affect the linear regression line? This single outlier present in the data can drastically shift the linear regression line to the right hand side as shown by the purple line. As a result, the threshold we determined before will also be affected and will change. This can make our model prone to error. Secondly, the issue comes with the interpretation of the model. Now consider that we want to examine the predictions when the training hours equal to 0 and training hours equal to 100. In the former case, the predicted value is negative 0.1, and in the latter case, the predicted value will be approximately 1.3. Now let me ask you something. Do these predictive values make any sense? Let's explore the answer in the next video. See you then.